Welcome to the linear equation portion of this tutorial. Recall that this is only one part of a much larger topic of algebra. In this lesson, we will be exploring the large pool of vocabulary and steps that are used when graphing linear equations. So let's begin with some background, shall we? Okay, so first off, we need to understand that a linear equation is an equation that is made up of two variables. One of these variables is known as the independent variable, while the other one is known as the dependent variable. The independent variable is called an independent variable because its value is independent of anything else in the equation. So for example, it may be a simple value of 5 or 7, 19, or 324,211. It doesn't matter, it's just a basic value that's independent of anything going on in the equation. The dependent variable, however, does depend upon what value is chosen for the independent value. So for the following equation, y equals x plus 2, x would be considered the independent variable and y would be the dependent variable. You could select any value for x, such as 5, this is independently chosen, and then y would become 7 since 5 plus 2 would equal 7. So y is dependent on the value of x that's chosen. So we have two variables. Great. X and y, they're mostly typical, although any other variable could be used. You could use s or t or w. In some cases, you could even use flower and happy face. All that matters is that we have two variables. So what else is in the linear equation? Well, that is all dependent on how it is written. What? Are you serious? Are you telling me that there are different ways of writing a linear equation? Well, of course. There are actually three different ways. First off, there is the boring standard form. This looks something like 3x plus 5y equals 15. So we have two variables. Yay! X and y are present. Good. But we also have two other things. We have an addition operation which separates the 3x and the 5y. And we have the flagship symbol of the equal sign. In fact, it can't be an equation without the equal sign, so that's always needs to be present. Okay, so we have 3x plus 5y equals 15. This is our standard form. That last 15 is known as the constant term, and that is the last portion of the equation. This is the standard form, and that's only one of the three ways that it can be written. So a second way to write a linear equation is the slope-intercept form. Wow, that kind of sounds complicated even saying it. Well, if we weren't such experts at this basic understanding, it might be a little difficult, but luckily, we're not afraid. We got it. Okay, so let's tackle this new form and look at the style of how the linear equation is written. We can start with the two basic words, slope and intercept. After all, it's called a slope-intercept form. So what exactly are these? Well, what is a slope? If we were to take a look at the Google search and take a look at a simple definition, the definition of a slope is a noun, a surface of which one end or side is at a higher level than another. Okay. Not sure if that really helped. Maybe it's a verb. Be inclined from a horizontal or vertical line, slant up or down. Well, that's sort of clearing things up. Well, luckily, it's not quite as bad as it sounds. Slope is a number. It's a number that measures how steep a line is when it's drawn on a graph. That's all. Pretty simple. A slope can be positive, negative, 0, or in some cases it could not even exist. A slope is written as your favorite F word. Yep, stop screaming. It's okay. The slope is a fraction, but it's not as bad as a fraction that might come back to bite you in your nightmares. We could take a look at just the basic common concepts of denominators and numerators, and we can see that the slope is actually very friendly. Start off, looking at the two numbers of your fraction. The numerator, the number on top of the fraction, it's represented by the rise, how far up or down the slope is. So when we start talking about steepness, how steep does it get? How far up and down does it run? That's the numerator. While the number on the bottom, the denominator, represents the run, how far to the left and right. So with this ratio of rise over run, we can find the slope. Relax, don't worry, this will be rather easy. Soon you'll go back and be happy that you had taken the time to understand slope. The numerator, okay, so now we've talked about slope. The intercept. The intercept is, well, think of it kind of like a football game. You know how the one guy, the quarterback, throws the ball to the other guy, the receiver, and one of the enemy team tries to get in the way, the defensive guy tries to get in the way and catch the ball. This is known as an interception. This comes from the root word of intercept. The intercept basically is where the one path of the ball is intercepted by the one path of the receiver. Where those two intersect is known as an intercept. Well, in math terms, on a graph for linear equations, the intercept is basically where the graph, the line, is going to cross one of the axes. In this case, the y-axis. So the intercept is talking about the y-intercept, where the graph is going to cross over the y-axis. So now we have our two parts. We have the slope and the intercept. The slope being the fraction rise over run, the intercept being where it's going to touch the y-axis. Alright, so let's see if we can put this all together. So let's look at an equation, y equals 1/2 of x plus 3. So we know that the x is the independent variable, the y is the dependent variable. Okay, check, got that. So now we take a look and we see the 1/2, and that's separated by the numerator of 1 and the denominator of 2. Okay, we also have a plus 3, the constant term. So taking a look at it in this form, we can see that the slope is going to be the rise of 1, the run of 2. So for every 1 up the line goes, it runs 2 to the right, being that they are both positive. We also know that the line is going to cross at the intercept of 3, meaning here on the y-axis at the value of 3, the line is going to cross. So that's not so bad. We basically have an idea. The line is going to cross at 3, and it's going to go up 1 over 2, up 1 over 2, up 1 over 2, and this is going to form our line. Well, that's not so bad. Not so bad at all. Okay, so we have the slope-intercept form, and don't forget we had the original standard form. Okay, that's not so bad so far. So we only have one form left. Well, it's called the point-slope form. Well, with 2 down, we have the standard form and the slope form. That means all we have left is the point-slope form, the third. So far it's not so bad. Let's take a look. We know that the slope-intercept was all based on the two words slope and intercept. Well, point-slope form works much in the same way, only now we're going to be looking at a point and a slope. Makes sense, right? Okay, good. We need to have a point, and points are written as an ordered pair of x, y. We're also going to need a fraction for the slope. Don't scream, it's okay. We saw fractions are okay. So let's take a look at an example. We'll have y minus 2 equals 1/4 times the quantity of x minus 5. This would be a good example of a linear equation written in point-slope form. we can take a look and see that the point is going to be consisted of the xy, which the x value will be this value 5, and the y will be the value of 2, and the slope would be this fraction right here of 1/4. Well, okay, that's not so bad. Let's see. If we take a look, we can see that the line is going to cross at the point 5, 2. Okay, that's here. And it's going to have a rise of 1 and a run of 4. Okay, that's not so bad. So point slope is not that terrible. So we have our standard form that has the x and the y, the flagship of our constant term. We also have the slope-intercept form, which has a slope of a fraction, and which that's our rise over run, good, and the y-intercept where it touches the y-axis, okay. With our third form, we have the point-slope form, and the point-slope form has a fraction, again with the rise over run, but this time it has a point in the ordered pair of x, y. Okay, so that's not so bad. This is actually turning out to be pretty easy. And in order for us to graph, we just need to use this information properly. Oh, all right. Let's take a look at those 3 examples and in 3 different ways and see how we can graph them and choose. Let's start with these 3 examples.